If you are a beginner and Proteus look confusing, don't worry. In the next few minutes, you will be confidently make and simulate your own first circuit. So first question arises in our mind, what is Proteus used for? So they are used for design, simulate and lay out the electronic circuit practically for PCB development and microcontroller programming. Now the next question, why use a Proteus? That's very important. So Proteus is widely used for cost-effective and professional software for schematic design, circuit simulation and PCB layout. It's essential for rapid prototyping if you want, enabling the engineers to test the microcontroller based circuits, analyze the complex mixed mode simulations and debug the virtual hardware before physical productions. It's very important for this one, and that save your time and development cost also. Now in this tutorial you will learn the simple LED circuit, how you simulate it. Then we see the Arduino simulations, how we can add the Arduino in our Proteus, and after that how we make the complete simulation using the HEX file. So, and then we see the basic PCB basics in the Proteus. So I hope so you understand what we are going to be learn. So now let's start. This is the first interface which you are watch when the Proteus is run. Right now I am using the Proteus 8 Professional. So now after that if you want to be see how you can download it, then the video in the description, the link of that video, and also you search on my YouTube channel. There's the lot of videos on how you can download from the professional source and how you access the full version. Now there are the different way to creating the new projects. First of all, I show you the professional way. It's like from open project and new project. This one, click on this button. Now they ask you to set the name and the path. So you can set the name from the dot up to the dot. You don't be change the dot pdsprj. Okay, that's the important, otherwise the file is not created. So I say that my one, and now the path, if you want to change the path, click on this browser and then you can change the path. Okay, but right now I don't be changing my path. Okay, this is our new project. And if you want for development board, then you click on this one from development board. In the next topic, when we move forward, then I show you how you can create a development board also. So there are the different development boards which you can choose from here. Right now I'm just say that it's the new project. Click on next. Don't be change anything from here, default. Okay, because if you don't want to be create a schematic, then you need to click on it. Otherwise, if you want to create a schematic, then you click on it, and these are the templates like landscape A0 up to portrait A4. So I say default, click on next. After that he said that don't create a PCB layout, but okay, right now in this project we are not going to be create a PCB layout. It's just the simple understanding and the few interfaces. I just explain you the interface and then few features, and then we make the circuit, or the first circuit on a Proteus. So right now I click on next, and after that no firmware project, because yeah, that's not microcontroller related. Click on next and click on finish. So in that way your project is created with the name my one. Okay, now after that, that's the interface. This is called the canvas. Here you can, this is the component mode, where you go into the component mode and click on this P. It's mean pick device. So now pick device window is appear here, and now you can search different thing. If I want LED, then write down the LED in the keyword, and now you see LED. This is the generic LED, and this is the LED which is animated. This is the animated LED mode. So now here you see the device name. This is the library, in which library they are relying, and this is the description of it, so which help you to choose your device. This is the LED purple. Name is very visible. This is the active, into the active library. What is the description? Animated LED model purple. So you understand completely what's that component are going to be do. So now this is the LED BB active. So this is called animated BI color LED model, blue to yellow with self flashing. So they explain the components very well in the description, so you can simply understand it. And if you want to be place it, then simply double click on it, then you see they are selected into our canvas. So now into our list, this is the component list. So if I click double on the different components, then they are all selected here. So in the next one we can just select it from here and paste it in our canvas. So first of all we need to pick the devices, so in that way you can pick it. Now this is the run stop buttons. That's very important. When we make the circuit, then we can run it. So now that's the time for picking some other component also. So now I pick the DC source. Now you see this is the battery. He said that DC voltage source, and this is the DC current source, and this is the DC voltage source. So description V source. I double click on it. After that I need the resistor. This is the resistor. They say that analog resistor primitive. Okay, so I double click on it and they are added. Okay, and then I close it. After that I need the source. I place the source here. How I do it, I simply click on it, they are selected and it's visible here, and after that I just place it anywhere in the canvas by the right click. Okay, if I don't want to be placed, then I click the left click, then it's unselected. If I want to be placed, then I need to select here, then it's visible here, and after that I can place it anywhere. Now I need a resistor, so I paste the resistor here, and I again want to be paste a resistor. So if you want to be rotate, then you can paste it here. After that you click on the right click on it, and there you see the different kind of settings are open there. So you can rotate clockwise, so if you want to rotate anti-clockwise, and rotate 180 clockwise. Okay, this is the short key num minus and minus plus. So these are the short key you can also utilize for it. Now this is the circuit. If you want to be zoom in and zoom out, I want to select that area, it's completely zoom in, then I can do it from here, zoom to area. I click on it. After that I just select the area which I want to be zoom in, then that area is zoom in. This is the zoom out, this is the zoom in, and that's zoom to the view the entire sheet. So this our entire sheet. Okay, you see the blue line, this is our entire sheet. Now if you just paste the component here, they are simulated, but if you want to be exported and if you want to be make a print, then they are not added in your print and export. So I again select this area. After that, the wiring, that's very important. Now into the Proteus you don't need to be select any kind of wiring tool, because when you come on the canvas, then you see this pencil tool, this is the wiring tool. So when you paste any kind of component, then you need to be simply left click on the terminal and go, and again left click, then it's wired. Now if I move there, you see this is the red kind of dot, it's mean that is the terminal which is allow us to be wired. So I left click on it, again I move. Now I want to be turned here, again left click. So now after left click I just make a turn, 90-degree turn up and down. Okay, so now paste it. So in that way you can do the wiring. Okay, now that's the wiring of our circuit, right? Okay, now if I want to be add a ground, so I need to be go into the terminal mode and choose this ground here and paste it here. Now I paste it here. That's the 1 volt. I need to be double click on it, double left click. There is the voltage 1 volt. Instead of 1 volt I said that 9 volt, and I choose, okay, this is the 9 volt, that's the 10k, and that is the 10k resistor attached in series. Now that's the time for run that circuit. So I simply click on run button here. Now this circuit is running. Now there is the option for pausing the circuit. In that way circuit is paused. So this is the stop button. When you stop the button, then you can edit it, otherwise you can't edit in the condition of start or in the condition of pause. So our circuit is running, but it's not visible anything. Why is it not visible? Because we just connect the resistor, that's the voltage divider circuit, which is just dividing the circuit of dividing the voltage across these resistors. Okay, and how we can see it, go into the virtual instrument. That's very important. There are the lot of instruments which we use to be analyze it, and there are the also instrument which allow us to generate the waves and different things okay, clocks like that. Okay, now I go with the DC voltmeter. Right now that circuit is DC, so I choose the DC voltmeter, place it here and attach in parallel, because if we want to be measure the voltage, then we need to attach the voltmeter in parallel with that resistor. Now I again run it. Now you see this is the 4.50 volts across this resistor. That's very good. Okay, now if I want to measure the current, how much current is flowing there, so now this is the DC ammeter. I choose it. That's the DC ammeter. Now after that I need to choose the selection mode. Now I select that wire, delete it here. Why? Because the amperes can't be measured in parallel, it's measured in the series. Okay, so now again I need to be do the wiring with series, in a series of the ammeter. After that I simply run it. Now you see they show me 4.50 volt, but amperes it's show me 0.00 amperes. Now I stop it. Don't be confused, it's not like okay, amperes are not measured right now. There is the problem of in the properties. So double left click on this ampere. Now you edit components, you come in the properties of the ampere meter. In the ampere meter he said that display range, that's very important. Click on it and you know they are measuring the amperes. So right now in our circuits maybe milliamperes are flowing. So I click on milliampere, click on OK. Now you see MA is written milliamperes. Okay, now I run it. Now you see 0.45 milliampere current is flowing across this circuit. So I close it again, double click on it, go into the display range and choose a microampere. Okay, now you see this is the microampere sign visible on a ampere meter, DC ampere meter. I again run it and you see 450 microampere current is flowing. Okay, so in that way you see the current is flowing and you see the voltage across this resistor R2. Now if we want to be this is the DC voltmeter, I again choose it. Okay, for choosing, okay, you see I choose the DC voltmeter but it's not visible here. That's why I can't be place it here. So first of all I need to be go into the virtual instrument and then choose the DC voltmeter. After that okay, there is also one more method. I go into the DC voltmeter, it's chosen, it's visible, this is the display screen, so I can rotate it here. Now you see it's rotated. Okay, now when I pasted, so it's pasted in the form of which I rotated. Okay, now I paste the voltmeter also here, and now you see the 4.50 volt across this, 4.50 volt across this, and 450 micro ampere current is flowing across these resistors. Okay, so I hope so you understand the basic circuit. Okay, and grounds are very important. In the case of DC circuit, the Proteus is not creating a problem, but in the case of AC circuits they are creating a problem. Now that's the time for pick the device. I again go into the pick devices and here I search the AC source. Now you see this is the AC source, which is called alternator animated AC voltage source. Okay, now this is the DC voltage source. There is only sine wave AC current source. So you need to be read down a description. That's very important, which give you the understanding which components you want. So I want this animated AC voltage source. I double click on it, click on OK, and I paste it here. I remove this DC volt and I attach it here, and after that I run it. Now you see the circuit is running, but they are not measuring the voltage very well. The current is also fluctuation. Their voltage difference also fluctuating here. Why? Because we are using the DC voltmeters and DC ammeters instead of AC voltmeter and AC ammeter. Okay, so I removed this one, and now I go into the instruments, or into the instrument I choose the AC voltmeter. First of all, this is the AC volt, paste it here and run. If you want, you can pause it here, you can move it from here, which show you the highest voltage potential difference across this circuit, which is 2.68 AC volt. Okay, I pause it here. Okay, I go into the AC volt, and now you see this is the amplitude. This is the 6 volt amplitude and frequency is 1 hertz. Okay, now I make it 60 hertz frequency and amplitude is 220 volt. Okay, click on OK and then I run it. Now you see the fluctuation is going to not right now. The fluctuation is not happening. The circuit is in the running condition because the amplitude, the frequency is higher. When you do the frequency very little, like 1 hertz, 10 hertz, then the fluctuations are happening into the measuring. Okay, now the 77.7 AC volts across this resistor. So I close it here and I want to measure the current across that loop. So I go into the instrument, I choose the AC ammeter, I place the AC ammeter here in series and then I run it. Okay, I need to make it into the microampere. That's very important. The time constant, okay, don't be change this thing. 100 milliseconds, it's okay. The display range you can change according to your circuit. Okay, again run it. So he said to me max, it's mean it's not possible to be measure the AC current in a microampere right now. So I need to be stop here and again open it and go into the display range, choose the milliampere, click on OK, and now yeah, that's the 7.77 milliampere AC current is flowing across the circuit. Now we pause it here. Now that is the time for the oscilloscope. In the instrument, oscilloscope is very individual, or we say that very unique feature which the Proteus give you. So oscilloscope give us the functionality like the other in the real life. The oscilloscopes give us, like, we can measure the waves and we can analyze it. So into the Proteus you can also do it with this oscilloscope instrument. This is the virtual oscilloscope. So I connect a B here and I connect the C with a ground. Now we run that circuit. In this oscilloscope, digital oscilloscope is opened in front of us. So now we connect the 3 channels A, B, C. So there are the lot of options there. So I make the complete video on oscilloscope on my channel. That's the Proteus in detailed video, but it is into the Urdu language. So if you understand Urdu language, then it's very helpful for you to be analyze the oscilloscope completely. That's the, I think so, 10-minute video which is just explaining the oscilloscope functionality from scratch to the advanced level. Right now I just quickly give you this some understanding of oscilloscope. So first of all, if you want to close the channel, then just close it. Okay, now channel A is closed. If I want to close channel C, I closed it. If I want to close channel B is also closed. If I want to close channel D is also closed. I open the channel A. Right now we have the AC circuit. This is the different kind of length which we created. Now you see perfect one. Now that's the visible. So they are just shrink and expand in the vertical way. If you want to be horizontal way, then that is the dialer, you say that, which is used for horizontal shrinking and expanding the wave. Okay, and in that way you can do it. Okay, so you can analyze it how that's happening right now. Now I open the B channel also. So this is the B channel. I open it here. I make it smaller. Okay, now both are on the same scale. It is the 50 millivolt and it is the 50 millivolt. We make this smaller, and this is the same one. So we just make it on the each other voltage. In that way you see the waveforms. Okay, how they behaved. So that's the oscilloscope working. Okay, if the oscilloscope is not opening, if you just run the oscilloscope and you see the oscilloscope window is not in front of us, so you go in And into the debug, you see this is the digital oscilloscope. That's only visible when oscilloscope is used in the canvas. Okay, I again click on it, and now the digital oscilloscope is come in front of us, and I can also close it from here. After that, I just be pause it, I remove the oscilloscope, and now that is the time for now. So I just be attached the one resistor 220 with this lamp. Okay, now that is the graph mode analysis right now. So in the Proteus, they are the one most important feature in the simulation also, which they give us. It's the graph mode. So into the graph mode, this is the graph mode, click on it, and there are the different kind of analog graph: digital, mixed, frequency, trend, transfer, noise, disturbance, Fourier, audio, interactive, confirmation, DC sweep, and AC sweep. So you can in any kind of analysis which you want, so through this you can do it. Now into the graph, we need to click on this analog, and now I paste the graph here. Go into the terminals, probes, and into the probes we choose the voltage and paste it here. And now after that, R12 probe is pasted here. I need to be just drop it, hold and drop on this analog analysis, and again run that circuit. And after that, I need to be left click on it and click on simulate a graph. Now that graph is simulated, and by double clicking I just be make it bigger. So now in that way you see the complete graph. The graphs are working in that way. From this graph mode, you need to be choose a graph, which graph you want to be draw. From this probe mode, you need to be choose the probe. You want to measure a voltage, you want to measure a current. I'll show you the properties of that graph. Double left click on it, and this is the start time and this is the stop time, so you can change according to your. Now that is the time for the Arduino simulation. So first of all, you need to be download the Arduino library. So I choose this Arduino Uno library. So that's my website, and on my website this is the web page where you see the 69 libraries available. So you can simply click on it and click on download button, then that library is directly downloaded after a few seconds. Now Arduino Uno library is downloaded. So first of all, extract it here, open it here, go into, and this is the library file, copy it. Now this is the Proteus 8 professional desktop icon. I click on it, and after that open the file location. So we are into the file location. Go behind, and there is the, we need to find the library folder. Okay, so maybe into the data there is the library. So in my case, into the data, the library folder. Maybe in your case the library folder is visible here, or maybe into the min, the library folder. So you need to be find the library folder. Okay, in my case it is into the library, because different versions have the different places for library folder. So into the library folder I click on it, and after that I paste it. Now they are pasted here. So after that you need to be close the Proteus and again run it. Otherwise your latest added library is not visible in your PIC devices. Okay, now we move toward how we can use the Arduino library which we added right now, and after that I show you the complete circuit we make with this. Now the second method of going into the schematic capture, it is in this short key. Click on it. This canvas is open in front of us. This is the schematic capture canvas. So now we go into the PIC devices, and here I search the Arduino. Now there is the lot of Arduinos are here which I already added. So this is the Arduino. I double click on it, and they are visible in front of us. This is the Arduino. Okay, now that is the Arduino which we use to make the circuit. So our basic target is simply make the circuit like LED circuit. So I need a one resistor. I choose it, resistor. I need a LED, and I need a green LED also. So now first of all I choose the one resistor, paste it here, and I need a LED green, paste it here, and after that I choose the ground and paste it here. And now I do the wiring very quickly. I connect the resistor with the 12 number pin, and after that I connect the series with LED and ground it. Okay, I change the value from the 10k into the 220, only 220. Okay, now that's our circuit. complete circuit. And now this is the time for the write a code. So because the Arduino without code is not working on Proteus also, so we need a program file. So for this one we need open the Arduino IDE. Now Arduino IDE is opened, and here I need to choose a few new sketch. Board is chosen, which is Arduino already. Make sure board is right. After that I go into the file, I go into the examples, and into the basic example I go into the blink one. So I want to be open the blink example instead of I just be write a code here. Now this is the blink example. This is the void loop. He set the LED built-in pin, okay, as output, which is the 30 number pin, okay. And now this is the LED built-in low. After it's just be blink in and blink out after the delaying of the 1 second only, okay. Now I define the LED built-in. Instead of 12 I just be say it's 12, okay. Sorry, instead of 13 I say it's 12 because the LED built-in mean 13. Right now I define the LED built-in this keyword, it's 12 pin, okay. So now after that I need to be click on this verifying button. Now they are verified it, and okay, that's very confusion for the new person which just be first time trying to be simulate the Arduino on a Proteus. Okay, that's code is just be like compile on this Arduino IDE, and how we can link it with the Proteus, that's very important one. So now into the output we see a lot of files, URLs are there. So we need to be find out the hexa file here. This one you see, C user, my computer name, then app data, then Arduino, then sketch, and this is the end with dot hexa, okay. I need to be copied. I copy that URL, I go into the Proteus, double click on it, and into the program file I paste it here, and I click on OK. Now our code hexa file is pasted in this Arduino, and now I run the Proteus. Now you see our code is working fine. From the 12 number pin the LED is blinking for a 1 second and then off after a 1 second, okay. So in that way you can write the Arduino code. Any kind of Arduino code you can use it here, which you want, and they are working very well. Now that's the different task. I just want the 10 number pin, like this 10 number pin with connect with the one resistor, and then I connect it with the LED. So first of all I pick the LEDs, like LED red. So this is the LED red. Then I pick the LED green, then I pick the LED yellow. This is the LED yellow. Now I just make it some bigger here, and after that I just choose one resistor here, paste it here, one resistor, paste it here, and then I choose the LED yellow here, and I choose the LED red here. I do the very quick connection, A11. Now I choose the ground for these and connect it here, okay. After that this is the LED green, this is the LED yellow, and this is the LED red, and maybe you understand what I'm trying to be making. So I use the ChatGPT for writing a code. Now this is the complete prompt which I give him. Write Arduino code for the light controller, which the LEDs are connected. Red LED connected with the 12 number pin, yellow LED connected with the 11 pin, and green LED connected with the 10 pin. Okay, now they are writing the code. That's very easy code. They just be pin definition, just defining a pins, okay. After that in the void setup they are say this is the output, and now they create a loop. That's the basic controlling, okay. Just we copy it, go into the Arduino IDE, paste it here. This is our complete code, and verified it again. They are verified again. We need to be scroll down and find out, okay. Make sure, okay, how you can find out. Maybe you say that okay I don't find out. You see these lines, 3 lines or 4 line, 1 2 3 4. So from these 4 lines you find out the hexa file URL, okay. This is the 4th, mostly into the 3rd line, this one, okay. Into this 3rd line I find out the hexa file. So I just copy from this C to this hexa file, go into the Proteus, double click on it, changed here, click on OK, and now I run it. So first of all, the LED number green is blinking. Now the yellow LED is blinking. Now the red LED is blinking. And okay, this cycle is unlimitedly repeated itself. Red LED to the green and then yellow LED. Okay. So this is the circuit of 555 timer IC which I made already, and now I show you how we can make the PCB board. So this is the beginner friendly tutorial, that's why it's very basic circuit. So first of all, you need to be open the PCB layout. So click on this PCB layout, then in that way PCB layout is open. Very few things. This is the PCB canvas, it is black. This is the again like the schematic layout, there is the options for the PCB layout. Okay, and here we see when we select one thing, then it's visible here. Below is also very important functionality, and there is also very important things. Okay, so there is the selection tool, and this is the component mode. So you click on this component mode, and first important thing you see there is the cross is visible there. It means these components D1 it's LED, this don't have the PCB package, and this V1 also don't have a PCB package. So now first of all, I show you how we can make the packages, PCB packages for the basic components which don't have. Now that is the time for making the board dimension. So for board dimension, again you need to be choose a 2D graphics because our board is in rectangular shape. Choose the okay, board edge, not top silk this time, and we want a board. I make a board 16mm by 14mm. I open the 3D visualization. Now this is the 3D visualization of our board which we right now made, and this is the time for placing a component on it. Maybe your board selection is like bigger according to your components, so don't worry. In when we place the component, then we make it bigger and shorter also. It's not like just one time you create. So I go into the components. I first of all choose the IC 555 timer, because if you have the IC in your circuit, so make sure go with this IC. Okay, I just be rotated here and place it here. Okay, after that I have a capacitor, so I just be place the capacitor one here. We have the 3 resistors. First resistor, place it here. Second resistor, place it here, and then place it third resistor here. And this is the terminal battery. I need to be rearrange after that. Okay, so this is the LED. Now I rearrange my components. Okay, I just add the capacitor here also. I choose the capacitor here. Now the resistor, one resistor is here. A rotator resistor. Now rotator resistor here. Now I place my component here, and after that I can make this smaller, this board. Now that's our board here. So we open the 3D visualization. So that's our visualization. This is the back side of the PCB board, and this is the front side. So there is the IC, this is the resistors, capacitor, and the LED, and there is attached the connector. So for the PCB layout, you need routing, and there are the two methods of routing. First of all, manual routing, and second is the automatic routing. So I show you first of all manual routing. For manual routing, you need to be choose this track mode, and from this track mode, this is the default, and there is the different dimension of your routing. Okay, so if I choose this T6, so you click on it, and after that it's give you the instruction from where you need to be moved. I just be move here and place it here. Now you see the thickness of this routing, it's small. Okay, if you want a bigger thickness than this T50, click on it. Now you see the thickness is bigger, so it's give you the completely understanding how you can go there and place the component. Okay, this is also connected, so in that way you can do the manually route whole thing. This is a small circuit, you can do it, but in the case of bigger circuit, it's very difficult. That's why we first of all make this schematic capture, because with the help of schematic capture the auto routing is possible. So I just be Control Z here. Now I choose this auto routing. This is the auto router, click on it. So this is the default options. So if you want to be changed according to your specific requirement, then you can do it. Otherwise, by default, this is good. But with the passage of time, you understand why this is important. Okay, so this is the wide grid. This is the 25th grid and 25th grid. So right now, instead of I show you some settings, I just click on this begin routing, and you see the automatically routing is start. This is the automatically routed. You see this is the red line. That red line mean you need that's in on the second layer. That's not on a first layer. Wide yourself. Now I show you the 3D visualization. We go into the back side. So in that way, when you do the routing, then it's visible on your PCB board. I hope so you understand how you can do the PCB board. And now we move toward making the Gerber file. So what's the Gerber file? That's come in your mind if you don't know about it. It is the standardized file format used in electronic industry to describe the image of printed circuit board PCB. It contains essential data such as copper traces, insulation layers, drill holes, and other information necessary for PCB manufacturing. So that's Gerber file is very important when you try to be send any kind of other company which make your PCB. Okay, so we come there, click on output and click on generate the Gerber file. Click on yes, click on close here, and after that this cadam Gerber and epsilon output. So first of all he said that steam file name. I said that my first, and this is the folder where it's going to be saved this Gerber file. And after that, this is the layer. So that's very important. So you choose top layer, bottom copper, top silk. Okay. Okay, we don't have a bottom silk. In that way, our components are attached on the top side. Top resist, bottom resist. We don't have a bottom resist. Okay, but okay, if it's selected, it's not big deal. Top paste, bottom paste. Okay, it's not selected. Top accessibility. And after that he said that this is the different slots and drills are chooses. Make sure Gerber format RS274X it's chosen here. Okay, and resolution 500 dpi, it's good. And then click on OK here. Now these are the Gerber files which they created. So you can share with the company, maybe GLC, which are making your PCB. So I hope so you understand how you can make the PCB board, the first PCB board on your Proteus. So if you like this video, please subscribe and share this channel also. So please share this video with your friend which